Okay, today we're going to look at a set of real numbers. Real numbers are basically all the numbers you've ever worked with in math. The natural numbers are the counting numbers, 1, 2, 3, 4, on into infinity. The whole numbers are the natural numbers plus 0. And the integers are all the counting numbers, but including 0 and negative counting numbers like -1, -2, -3. So there, when you look at this Venn diagram, there's natural, the natural numbers are part of the whole numbers, and the whole numbers are part of the integers. Well, all of those integers, whole and natural, they're all part of something called the rational numbers. And what are rational numbers? A rational number is any number which can be written as a fraction of integers, a ratio of integers, a over b. But b can't be 0. You're not allowed to divide by 0. These are some examples of rational numbers. 2 over 3, 5, 3 and 4/7, root 16, 1,25, and 2.13 repeating. That's 1313 going on, a repeating decimal. Now this you can see is a ratio of integers, but 5, it actually can be written as 5 over 1, 5 divided by 1, and that's why it's a rational number. 3 and 4/7 is really 3 times 7, 21 plus 4, 25 over 7. So it can be written this way. And root 16, you might look at it and think, is that absurd? But the square root of 16 is just 4, and that can be written 4 over 1. Now 1.25, that's really 1 and 25 hundredths. And 25 hundredths is the same as 1/4. And 1 and 1/4 is really 5 over 4. So look, 1.25 can be written as a fraction of two integers, a ratio of two integers. We're going to learn how to turn any repeating decimal like 0.13. If you do this on your calculator, 211 divided by 99, you'll get 2, 131313, and then the 1-3s keep on repeating. So those are the rational numbers, and they include all the counting numbers, but there's any fraction you can make. Anytime you can make a ratio of integers. Now, there's another set of numbers, the numbers that you can't make as a ratio of integers. They're called irrational numbers. An irrational number is any number which cannot be written as a ratio of integers. Now here's some examples that we'll run into. The square root of 2, pi, the distance around a circle divided by the distance across, the cubed root of 10. And then maybe something like this, 1 plus root 3 over 4. Well, you know, you can use your calculator to sort of check if a number is irrational or not, because irrational numbers have decimals that have no pattern, and they can't be written as a ratio. So there's no repeating decimal, and they don't terminate. So if you take pi and put it in your calculator and press equals, you'll get this 141592, and there'll be no pattern. It just goes on forever. If you had a powerful enough computer, it'd have like, you could go on forever and you'd never see a pattern. The square root of 2 is the same thing. You get 1.41 and then decimals that just don't repeat. Well, if you add a third, like the square root of 3, like 1 plus root 3 over 4, you'll get the same thing on your calculator. It'll be irrational. You can't write this as a ratio of just integers. And some other things like cubed roots and fourth roots, if they don't work out to be an even number, then they're irrational. They can't be written as a ratio of integers. Well, I hope that helped. That's what the real numbers are about.